Welcome to This Explainer. We all use ChatGPT, right? And honestly, from the outside, its sudden, incredible fluency just feels like magic. But I'm here to tell you it's definitely not magic. It's actually a highly engineered, shockingly massive digital assembly line. So today, we're totally taking apart the machine to demystify exactly what happens under the hood.
Okay, let's dive into this. How is ChatGPT actually made? It's incredibly easy to just think of artificial intelligence as this digital brain that suddenly woke up in a lab somewhere. But the reality is way more structured. It's an incredibly methodical, precise recipe, built on thousands of high-powered GPUs just churning through petabytes of data. As you'll see, it's a very strict combination of immense raw data, specialized neural network architecture, and highly specific human fine-tuning. Here's our roadmap through the AI factory. We've got 5 distinct phases. 1. GPT architecture. 2. Pre-training. 3. Fine-tuning. 4. Safety and alignment. And finally, 5. Deployment. Keep this mental map handy as we go.
Section 1. The Foundation GPT Architecture.
At the absolute core of ChatGPT is a type of neural network called a transformer. This is literally the bedrock of the whole system. Now, this architecture wasn't just pulled out of thin air, actually. It was introduced by Google researchers in a pretty famous 2017 paper. And the reason this specific innovation changed absolutely everything is parallel processing. Instead of reading text sequentially, word by word like older models used to do, transformers can look at entire blocks of text all at once to mathematically weigh the importance of every single word against all the others.
Now, what's really interesting about this slide is how it breaks down what's actually happening when you see text appearing on your screen. There are 2 main functions going on. First, it processes context by looking at the deep relationships between words. Second, it predicts the next word based on all those learned patterns. It's not sitting there thinking up a whole paragraph at once. It's actually just playing the world's most complex game of fill in the blank at absolute lightning speed. It is essentially autocomplete on steroids.
Section 2. Massive data. Pre-training.
So in this stage, the AI acts like a completely voracious reader. The model is unleashed onto a dataset that's equivalent to millions of books. We're talking massive public datasets, scraping Wikipedia, Reddit, articles, forums, publicly available documents, just taking in everything to absorb the basic syntax and rules of human language.
By predicting billions and billions of missing words, the model learns human grammar, logic, and honestly, a dizzying amount of trivia. But here's the catch. This process creates what we call a raw base model. Yes, it's incredibly powerful, but right now it's basically just a massive mimic, a stochastic parrot, if you will. If you ask it a question at this stage, it might just answer you with another question. Why? Because it doesn't actually know it's supposed to help you yet. It just knows how to continue a text pattern.
Let's move to and see how this builds into Section 3, human feedback and fine-tuning.
Okay, so this is how we shape that wild, raw base model into an actual conversational partner. It's a very strict 1, 2, 3 process called reinforcement learning from human feedback, or RLHF. Step 1, human reviewers actually sit down and write out good, high-quality example answers. Step 2, humans look at a bunch of different responses generated by the model and rank them from best to worst. Step 3, the system takes all those human rankings and learns our preferences. This takes literal armies of human contractors globally. Think of it exactly like a teacher grading an essay. This deliberate manual process is how the language model learns to actually be helpful and accurate.
Section 4. Safety and alignment rules. Now, the developers have very specific safety goals in mind. They actively need to reduce harmful or biased outputs and absolutely ensure the model avoids giving unsafe instructions. Remember that raw base model we talked about? Without these strict extra guardrails, it could easily generate dangerous outputs or just wildly hallucinate facts based on some of the darker, unfiltered corners of the internet it read during that wild pre-training phase. So teaching it boundaries is absolutely crucial.
And this brilliantly illustrates exactly how those safety goals are practically achieved. It's a multi-layered defense mechanism. First, they filter the training data right from the jump. Second, they hard-code rules and safeguards. And third, they conduct ongoing testing. This often involves a really rigorous process called red teaming, where actual human security experts actively try to hack or break the AI just to find its weak spots before it ever gets released to the public.
Section 5. Deployment and continuous improvement. So the crucial point is, this process is never truly finished. It's a continuous loop. Once the model is deployed, millions of users instantly find new, bizarre ways to prompt and test the AI, leading to real-world edge cases. So developers constantly have to update the system with better training methods, inject new data within limits, and patch those safety systems. It is an ongoing, churning wheel of learning and refinement.
Because of this continuous loop, the AI you interact with today is quite literally not the exact same AI you're going to interact with tomorrow. The factory assembly line is just always running. So with continuous updates and vast new data constantly being fed into the system, what will the model learn next? Thank you so much for joining me on this explainer. Keep questioning the systems behind the screens, and I'll see you next time.